Hi everyone, can you hear me?
Yes,
Yes.
please.
Yeah, you're audible.
Just a moment, we'll get started. Very good morning and good evening, guys.
Good evening.
So, how many of you are joining today who are not part of Saturday's demo?
Hello, Suresh.
Uh,
I'm
I'm
new
not
to the
part of
session.
Saturday's demo, but I've watched the video.
Mhm. There are few. Okay. So, thank you for showing interest and joining our course, guys. I think first few sessions would be kind of demo only. So let's get started. Let me introduce myself. If you are not part of yesterday's demo, uh, you know, I'm Suresh, have close to 12 plus years of experience. Not 12 plus, close to 12 years of experience. Have been working as a data engineer right from the day one. I started my career as a Hadoop developer, then transitioned into Spark. Now I'm currently working on cloud. Predominantly into Azure and GCP. I do have hands-on with AWS, but not as much as in Azure and GCP. And currently, my role is a cloud architect. You know, uh, Driving various client projects, especially the data engineering architectures. That's one thing. And talking about my training experience, have been into training for from 2016. I started with Collabora, and then it's called TANT. Then I have worked for few Hyderabad-based institutes. Have been with Career IT for almost 6 years now, close to 6 years. Uh, I train folks on Python and data engineering. I used to train on Python, but now I'm not doing it. But yeah, I'm currently doing only Azure data engineering. Okay. So this is a brief introduction. And on Saturday's session, I have walked you through the curriculum as well, but you can probably get the curriculum from Career IT folks if you were not part of Saturday's session. Okay. So just want to give you an understanding on how your first week would look like. Uh, First couple of sessions we'll be talking only about basics, understanding, what data is all about, what cloud is all about, and then creating your cloud account, right? And then, we will slowly move into the data services. We will start with ADLS Gen 2, and all these things will happen in week one. Okay. Yeah, I just missed your message. Welcome back, Sunita.
Yeah, thanks, Suresh. Yeah.
Okay. So maybe first couple of weeks it's going to be boring for you, Uh, yeah, let's get started. Uh, Yesterday we were talking, few things about data, but I haven't deep dived. Today I'm gonna do that. But today is all about, understanding data, different types of data we have, and then different types of processing we do, so on and so forth. Okay. So let's try to make this session as interactive as possible, guys. You can probably unmute yourself and talk, or maybe you can use the chat window and ping your answers. If you don't want to ping it to everyone, you can ping it to me person. Okay. Let's get started. Data. So we are now, into data engineering course, right? Let's try to understand what exactly data is. Any idea? People who are part of my Saturday's demo should be knowing it. What is data? Unstructured raw information. Okay. I'm gonna ask this question multiple times, guys. Data is nothing but collection of raw facts. Okay. So it can be unstructured or it can be unorganized. It can be anything, basically it's a collection of raw facts. Okay. So data, to put it in a simple terminology, it's a combination of some alphanumeric terms. It could be only alphabets, it could be only numbers, it could be only uh, or it could be a combination of both. It could be date, it could be Boolean value, it could be anything, guys. Okay, but it is not giving you anything concrete. Okay. Generally, collection of raw facts. What exactly are these raw facts? Raw facts could be attributes. Talking about a product data, we'll have a unique identifier ID to identify that particular product. And then we have this product name, and then we have this product price, and then product image, right? So all these attributes of products, contribute to this product's data. Let's say talking about customers, we have customer attributes like, again, a ID, which uniquely identifies the customer. And then we have customer first name, customer last name, customer address, and then, customer preferences, whatnot. Okay. So this is what we refer to as data, guys. Okay, so data could be presented in multiple ways, which we are going to talk about, but this is what data is. Okay, and then we have another interesting term called information. Okay, so like I was mentioning in yesterday's demo, day before yesterday's demo, in general, we use information in the wrong context. Okay, so wherever we need to ask for some data, we use this term called information, and we can't refrain ourselves from doing that. Okay, so even after knowing the difference between data and information, we will still keep using the term information. Okay, so again, to put it in a layman terminology, information is nothing but processed data. Okay, so it could be some trend analysis, or it could be some, you know, something as simple as an average. Okay, uh, probably, if you are given a student's marks list, or maybe employee salaries of an organization, so just by looking at the data, you'll not be able to interpret anything. But if somebody tells you, the average salary of employees in this organization is 65,000, or maybe average hike of employees this year is 13%, or maybe 15%. It's been long time. We heard those numbers though. Okay, it's all single digit, but coming back to the context, average hike of an organization this year is 13% or maybe 15%, right? So that is something which is giving you some insights. Okay, so that comes after processing your data. So you have data of all the hikes and then you process it to calculate average, and that is information. Okay, or the average percentage of students. Let's say average percentage of students is 70, meaning you go pick any person or any student in random, his percentage would be in and around 70%. Okay, so you should always be aware of outliers. You will have somebody who is getting 90% and above. There would be people who are getting just 40%, 30% and failed students too. Okay, so these are what we call as outliers, but majority of the students would fall in and around that 70 percentage. So this is the basic difference between data and information guys. So data is collection of raw facts, it's unprocessed, it's raw and rustic. Whereas information is processed data. Okay, it could be as simple as average we discussed about, or it could be some trends, or it could be anything else which is processed and giving you some insights. Okay. Now talking about different types of data, we have a few categorizations here. One is on how the data is stored. Structured. We'll start with unstructured. And then we have something called a semi-structured. Any idea what is unstructured data? Can you take a guess?
Data that can be put in an Excel sheet or like something that cannot be organized.
So, like any clickstream data or email, social media post, anything which is not a relational sort of thing is unstructured. It's not like a formatted one.
Got it. And then we have one response in the chat. Videos, images, lack of predefined format. All these answers contribute to the question I have asked. But let me explain in a structured way. Okay. So unstructured data is something which doesn't have any structure attached to it. Okay. So what do I mean by structure here? Let me explain. So talking about unstructured data, right? You have a lot of verbose in it, a lot of what you call a lot of text. Okay. So for example, maybe I want to store data of a student in a file. Data of a student in a file. Okay. So it would be something like a student with name Suresh, bearing roll number, some XYZ, have secured X marks in subject 1, Y marks in subject 2, Z marks in subject 3, so on and so forth. Okay. So if you are storing data something like this, that is an unstructured format, guys. As simple as that. It doesn't have any structure attached to it. Best examples, whenever you are reading through some blogs, they mention that whatever data that is stored in files is unstructured. That's not completely true. Okay. But if data is stored like this in a file, is unstructured. Say, for example, your textbooks, your textbook PDFs, unstructured. Okay. Any books. It's not just textbooks, any books. Okay. And then all the multimedia data like images, videos, unstructured. Okay. So what is the disadvantage of this unstructured? There are two things, right? One is storage. And then the second one is the data retrieval. Okay. So why storage? Because just to store some important data or some important attributes, I'm storing a lot of text. Okay. A student with name, Suresh, bearing roll number XYZ, have secured, blah, 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 blah. So much of unnecessary data. or unnecessary text, I would say. Okay, and now let's talk about data retrieval. Let's say, I have some 600 students in a college. Okay, now I want to retrieve uh, maybe all the students who have secured more than 90 marks in subject 2. Okay, so how will I do this? Literally, I'll have to go through the entire file and then check for this text S2 and then see how many marks are tagged to the S2. If it is greater than 90, then I'll have to pick the name and put it in a different file. As simple as that. Okay, so just imagine you doing it manually for 600 students. Now, maybe I want to get the same at a university level. Now, this 6,000 will become 6 lakh, or maybe 2 lakh, 3 lakh. Doing it just imagine doing it manually. Okay, now this is students data. Now you think about your sales data. Maybe you want to see the highest transaction, or any transaction which is having a value more than $1,000, and you have some billions of records. Okay, so this is not going to be easy, guys. Okay, and few examples of this is the data stored like this in a file, and then images, videos, HTML files. Okay, and like somebody was mentioning, clickstream. So clickstream, again, it depends on how your data is downloaded to that file. Not every time clickstream is unstructured. Okay, so for people who doesn't know about clickstream, so clickstream is nothing but the data that is getting generated when you are making a click in a website. Say, for example, you are visiting a website, and then for every click you are making there, you are actually generating data in the backend. Okay, so that has different attributes or different information. It will talk about where exactly you have clicked, what exactly you have viewed. Say, for example, you are watching a video, how long you have watched a video, whether you have skipped it or whether you have completely viewed it. Okay, so the best usage is YouTube. Okay, let's say you're scrolling through the shorts, YouTube shorts or Instagram reels. Okay, so you will be repeatedly played with the videos which you have watched completely, but not something which you have skipped. Say, for example, you are getting videos in on some real estate. Maybe let's say you are looking to purchase a flat. Let's say you have watched that complete video, then you will start getting similar videos. Okay, but let's say after looking at couple of shots, you just skip them, haven't watched it completely, then automatically the topic will get changed. Okay, so this is one of the application of clickstream data, guys. So whenever you are clicking, a lot of data is being generated from what location you have made the click, IP address of your machine, whatnot. Okay, so not every time this is captured in unstructured format. My experience with clickstream is semi-structured. Okay, I'm going to talk about that now. To address this issue, people have come up with structured data. Okay, so structured data, rather than storing data on a file, like the way we have discussed earlier, they have tried to attach some structure to it. Something like this. I'm gonna pick the same student example. Okay, so from such a huge verbose, they try to identify some attributes, like what are the important features, roll number, and then we have name, and then we have or probably let me use my Excel sheet, which would look better. Okay, so they have tried to identify the attributes, roll number, name, and then subject 1 marks, subject 2 marks, subject 3 marks, and then we have total. Then we have what do you call, probably I'll pick percentage, something like this. Okay, Now let us assume we have roll number 1, name is Suresh, and then marks is 50, 60, 60, 50. Total is 150, 160. And then percentage would be somewhere around 53. I'm just taking some random numbers. I'm not calculating here. And then there is Ramesh. Let's say his marks is X, Y, and then Z. Total marks, some Z, or A, and then B, something like this. Okay. Now, if you see, this is more effective way of storing your data rather than storing something with a lot of text. You see, this is looking like a table, right? So structured data, when we talk about structured data, we basically store data in the form of rows and columns. It's a table, okay, where the vertical ones are called as columns and the horizontal ones are called as rows. So this 5, 6, 7 you're seeing over here are rows, and then this E, F, G, H, whatever you're seeing in vertical are columns, okay. And each column talks about an attribute. Roll number is an attribute, name is an attribute, S1, subject 1 marks is an attribute, so on and so forth. And each horizontal one talks about a record. We call it as a record. The 6 and 7 are 2 records for this table. You can give a name to this table students, something like this. Okay, so the name of this table is students, and then we have 2 records in this table, 6 and 7. Okay, so one record talk about one object. Okay, one student object. Okay, one student person, I would say. Okay, so here I'm taking student, but that would be applicable for any other things, guys. Maybe you take product data. Okay, so you'll have product ID, product name, product image, product price, and then product discount, whatnot, right? So these are all attributes. And again, one record would give you uh, the understanding of one object, one product object. Okay. Now, this first row, fifth, is referred to as header. Header or your attribute names or the column names. Okay. Roll number, name, subject 1, subject 2, subject 3, total, and then percentage. Okay. So definitely this is effective way of storing data. But what is this data? What is this about retrieval? Now going back to this, before I go there, I want to introduce another term called RDBMS. Okay, so RDBMS stands for Relational Database Management Systems. Okay, so basically this relational database management systems is a tool which would help you to handle structured data. Meaning this provides a provision for you to store data in a structured format in the form of tables, and it also provides you with something called as SQL. SQL stands for Structured Query Language. Okay, so how does this work? Now, let's say I am gonna pick the same example, guys. You want to get the students who have scored more than 90 marks in subject 2. I can simply write a SQL query, select star from students, where subject 2 is greater than 90. This is all I'll have to do. It will go fetch all the records for which the condition is getting satisfied. Okay. So even if you don't know SQL, even if you are not from ETL background or you haven't seen the basic SQL, just by looking at this statement or the SQL statement, you are able to interpret something, right? It's pretty self-explanatory. Select star stands for all the columns from table name is students, where subject 2 is greater than 90. That's the beauty of a SQL query, guys. Okay. So you're actually querying your RDBMS tool using this particular query. Okay, so we will learn SQL in the coming sessions. That's a different story. But yeah, so this RDBMS is a tool which would help you to manage structured data. When I say manage, store, and then retrieve data. Okay, there are multiple other operations you can do, but for a data engineer, these are the two things which is important. Okay, now moving on to the third category, semi-structured. Now, can you take a guess? Now you know unstructured data, you know structured data. Now, what is this semi-structured data? Any guesses?
So XML will be the semi-structured, right?
Yes. So talking about semi-structured,
And
right?
even emails or
Email is
job logs.
email is unstructured.
It would say semi-structured as well.
Again, as I was mentioning, right, it depends on how your email is downloaded. Okay, so for example, when you talk about a raw email, it's unstructured. Let's say you have downloaded your email in an XML format where you have the tags attached and then data attached. So that's semi-structured. Okay. So talking about semi-structured, it will have some structure attached to it, but they are not a typical what you call they're not the data is not typically stored in a table. Okay, so the best examples are things which Rajesh have pinged: JSON, XML, CSV. They're all semi-structured guys. Okay, so talking about this one, let me give you some examples. JSON stands for JavaScript Object Notation, where the data would be stored in the form of key value pair, something like this, ID, some number, and then key value pairs are separated by comma. Let's say second attribute is name, and then let's say third attribute is location. And then this value, Hyderabad, and then let's say fourth is some profession. Profession is, IT, something like this. This is how typically a JSON structure would look like, or JSON data would look like. So if you see, there is still some structure attached to it. You're storing only the attributes, ID, name, location, profession, but it's not typically stored in a table. Okay. So likewise, we have something called as CSV. If you have to store the same data in the form of CSV file, CSV stands for comma separated values. Okay. So you'll have a header, the first row. Again, it's an optional one though. Okay. But let us assume we have it, profession. And then, the data would be stored something like this, 1001, the name, then location, and then profession, something like this. And then you have something called as XML files, XML. So I'll be walking you through all these formats in the coming sessions, guys. We have something called as file formats topic when we are dealing with PySpark. We have libraries to deal with all these file types. So we are going to revisit them. Okay. So XML, so in XML, you basically assign structure in the form of tags, something like this. Okay. So for example, I want to store ID start tag, and then you'll have end tag. End tag is, end tag starts with /, ID, and then, here goes your value 1001, and then name data, or the name value, and then the closing tag. Okay. And then location is Hyderabad. and then closing tag of location. Okay, and then we have profession. Profession is IT, and then profession. This is an example of how an XML file would look like. Okay, so these are the few examples: CSV, TSV. TSV is nothing but tab separated. Instead of comma, if you have a tab as a field delimiter, a delimiter is nothing but a symbol or special character which separates two values guys or two attributes. So in this case, it's comma. It can be a tab, it can be a semicolon, it can be anything. Okay, again, we will talk about all those things when we deep dive into file formats. Okay, but for now, these are few examples of semi-structured. Semi-structured is nothing but the data which is still having some structure, but not typically stored in a table. Now, let me take a pause. Are we good so far?
Yes.
Yes, sir.
Okay. So the next categorization is transactional data versus historic data. Any idea? What is transactional data versus historic data?
Transaction is basically a real-time single transaction. Say for suppose a customer placed an order, it's a transaction. But if you are looking at his order history, then it's a historical data of that customer. It's basically
That's correct.
Transactional means it's a day-to-day activities data,
Mhm.
so which we can see live. But where historical means it's a past data.
Yes, that's correct. So both the answers are correct, guys. But I like this term. Day-to-day activities data. Okay, very layman terminology. Okay, I'll give you simple examples, guys. Like a couple of our participants have mentioned, transaction data is your current data, which you need to do your day-to-day activities. Okay, day-to-day activities where in your business. Okay, so for example, you want to log in to the Amazon website, or maybe Walmart website, or maybe any other website you do some retail operations. Okay, so you'll have to give your email and password, which is an example of transaction data. Okay, and then maybe you want to look at what products you have. Okay, transaction data, and then the customers transaction data. So all these things are which are used currently is transaction data. And what is this historic data? So historic data, again, what are the data that is not currently in use? Say, for example, you have purchased a product, okay, and the product has been delivered to you, and the return period is also over. So now it becomes historic data. Again, it depends on how your business defines it. There is no such rule like, one day after the purchase is over, it becomes historic data. It all depends on your business rules. Okay. Sometimes relevancy plays an important role, but historic data is past data. Again, this is not something which can be used for the live operations. Okay. So we use different tools and different techniques to handle this data too. Okay. So here we use RDBMS to handle transaction data, and we call it as OLTP engine. Online transaction processing. Okay, online transaction processing engine, OLTP. Okay, so the reason they are developed is totally different, guys. So this is used for live operations. Okay. And talking about historic data, to handle this, we have something called as data warehouses. Okay, and we call it as OLAP engine. So full form online analytical processing engine. Okay, and this is used for a different purpose, guys. This is predominantly used for building your BI reports, business intelligence reports, and using it for AI ML use cases. So for example, maybe I want to predict sales of a particular product in the next quarter. I should be analyzing my historic data and then see how I'm gonna perform in the next quarter. Okay. And even the way we model data is also completely different. So here we'll be sticking to normal forms depending on your organization needs, different normal forms for their first normal form, second normal form, Boy Scout normal form, whatnot. And here we'll be sticking to a different data model. Snowflake schema, star schema. So I'm not mentioning them, but something like facts and dimensions. Okay, so there are a lot of differences between transaction and historic data, guys. Okay, you know, but again, this is categorized based on the relevancy of the data. Okay, so anything that you need for live transactions or day-to-day activities in a particular business, that refers to transaction data. Okay, so there is data which you might not need for day-to-day activities in your business, but you still need it because data is gold. You cannot afford to miss data or lose data. Okay, so because storing all this historic data would help you better prepared for the upcoming quarters to improve your business. Okay, but are we good with the differences between transactional and historic data?
Yes.
So historic means is it related to the will it link up with the server or so
What is server? What according to you is server?
so we use like OLAP connection. We call like OLAP connection. So there will be some credentials. It will fetch from the backend server that connection. So
That's how you pull data with RDBMS as well, right, Rajesh?
yes, yes, yes. So for BI reports, so yeah, I used AO reports.
It's
Analyze of.
it's simple. A
Hmm.
server is nothing but a high-end computer. Agreed? To put it
Yeah,
in payment terminology,
correct,
you install RDBMS software on that server, it becomes your database server. Agreed?
correct.
You install data warehouse on that server, it becomes your warehouse server. Agreed?
Agree.
The way you connect with both these systems is again JDBC. Simple. It depends on what tool you are using. The JDBC URL will differ. Okay. But at
Hmm.
the end of the day, the components of your JDBC is the host name and then port number through which you want to connect, user ID, password. As simple as that. You have these four details, you can construct your JDBC URL.
Okay.
Okay. The way the way they work will be different. So basically, when we talk about this historic data, right, they are meant to support your BI reports or faster querying. Okay, and hence the concept of facts and dimensions came into picture. Okay, so facts are nothing but your metrics of your organization, of your business, and then dimensions which revolve around those metrics. Okay, and again, I don't want to deep dive into these facts and dimensions, but to cut short here and give you a better understanding, warehouses are meant to support BI reports and any machine learning algorithms you want to run on a huge data sets. meaning it has to be faster than a transaction. Okay. Does that answer your question, Rajesh?
Yes. I'm clear.
Okay. Now moving on. Types of processing. Batch and then real time. Any idea?
Batch is nightly processed, uh, or it ca- I won't go to the nightly, like any process you do together, you can say it's a batch. Real time is a each single transaction you do to the database.
That's correct, guys. Okay. So to put it in a simple terminology, right? Anything that is scheduled is batch. Okay. Let me pick an example. Let's say you have Amazon website, and then what are the transactions you are doing in Amazon website is being captured in RDBMS software. Okay. And then you want to move this data to Azure cloud, or let us assume AWS cloud since it is Amazon. Okay. Now let us assume this is one process, guys. This would happen uh in a transaction basis. As in when somebody is purchasing something, that would be reflected in the RDBMS. Now, moving those transactions to probably I'll take AWS Redshift. Okay. So talking about this particular process, right? How do you want to do it? That defines whether it is batch or real time. Maybe you want to do it once in a day, or maybe you want to do it twice in a day, or maybe you want to do it every 1 hour, or maybe you want to do it, every 5 hours or 6 hours. Okay. So that is what we call as batch processing. Okay. Like, one of our participants was mentioning nightly process. So generally, if there is a huge data that needs to be moved from source to destination, here the source is RDBMS and the destination is AWS Redshift. We generally schedule them overnight so that, the load will happen overnight and then morning we can just come and check if everything went well. Okay. So it need not be always overtime. It all depends on your business timings too. And talking about real time, this particular thing will happen on the go. So for example, some purchase has happened and that record is entered into this RDBMS, and the very next moment that will be moved to Redshift. Okay. So this is what we call as real-time processing, guys. So whenever you want to get things happen in real time, this is what it is. And you might ask me, boss, how real time it is. So generally, most of the real times are not exactly real times, but near real times. There would be some sort of a delay, at least, if not minutes, there will be few seconds delay. It's not like the moment it got reflected in RDBMS, it will move to Redshift. There will be very negligible delay, which is definitely better than scheduled. At least you'll have all the latest data moved to cloud on the go. Okay. So most of the times, that's the reason we refer real times as NRTs, near real times. Okay. But based on how your processes are running, we can categorize it into two types: batch and then real time. Anything scheduled, close your eyes, and it's called batch. Okay. So there is a concept of micro batches too. Sometimes, people who don't want to go with the real time, they generally go with micro batches, which runs every 5 minutes, every 10 minutes. Okay. So it's almost looks like a real time, but with some delay. Okay. Let me take a pause. Are we good so far?
Yes.
Yes, Suresh.
Okay. Cool. So we'll stop here for today, guys. And when we meet tomorrow, I'm gonna introduce cloud to you. So just a heads up what you're going to learn tomorrow. We'll start with cloud, try to understand what cloud exactly is, and then we'll talk about different types of cloud deployment models we have: public cloud, private cloud, and then hybrid cloud, multi-cloud, and then we'll talk about different types of services we have: SaaS, PaaS, IaaS, serverless. Okay, and then I'll be showing you setting up Azure account tomorrow. Okay, and day after we will be starting our first service in Azure, guys, which is storage account, ADLS Gen 2. Okay, so before I end this session, I'll be waiting for a couple of minutes if you have any questions.
So far, I'm clear, Suresh.
Cool. So if you don't have any questions, that's all from my side for today, guys. Thank you so much. And good day for folks joining from India, and good night for folks joining from US. See you tomorrow.